Assalamualaikum brothers and sisters. So now in this video we are going to continue with voltage regulator, but this time with a range of power supply. Okay, so in the previous video the voltage regulator is connected to a set value of power supply, right? But this time, what if your voltage regulator is connected to a range of power supply? So let's go back to the conditions in order to make sure that your voltage regulator works. So the first one is power dissipation must be less than the rated value. Okay, now this is the one that is important. When your power supply is minimum, there must be a minimum current in the Zener diode. We already seen that the Zener diode, there is a range of current IZ min to IZ max. So we have to make sure that the VPS minimum must be high enough to ensure there is a minimum current in your Zener diode. So now that your IZ is minimum, which means that your load here will have a maximum current. Okay, so when your IZ is min, your IL will be max. Okay, now if your power supply is maximum, the current in the diode will be IZ max. Okay, and vice versa, your load current will be minimum. Okay, so that's how it works when you have a range of power supply. So you know that Ri is equivalent to the voltage across Ri over the current I in. Okay, so VRI is equivalent to VPS minus VZ, and I in based on KCL is equivalent to IZ plus IL. Okay, so we already established this. Therefore, if your VPS is min, so the I in is equivalent to IZ min plus IL max. These two are together. Basically, if your VPS is min, your IZ will be min. Similarly, if your VPS is max, then IZ will be max and your IL will be minimum. So now that you have these two equations for Ri, okay, and if we equate these two equations, basically this equation equivalent to this, you will have this long equation here. Okay, and if you make the assumption that IZ min equivalent to 0.1 IZ max, your equation will be simplified further, and you can see that there is no IZ min in this term here, and you can use this to calculate your IZ max. And once you know IZ max, you can calculate IZ min based on this assumption, and you can also calculate your PZ max. Alright, so let's look at one example. So this is a voltage regulator here, used to power the cell phone at 2.5 volt from a lithium ion battery, which voltage may vary between 3 and 3.6 volt. So the keyword is vary between 3 and 3.6. So you know that you have VPS min and VPS max. The current in the phone will vary 0 to 100 milliampere. So the phone here is your load. Okay, and you are given the IL min, which is 0, and IL max is 100 milliampere. You are asked to calculate the value of Ri and the power dissipation of your Zener diode. Okay, so when you see this kind of question where you have variation in the VPS and variation in your current, definitely you are going to use this equation here. Okay, the voltage of the cell phone is 2.5 volt, which means that this is your VL. And because your Zener diode and the load is in parallel, indirectly the question is giving you what is your VZ. So VZ is 2.5 volt, right? So in order to use this equation, let's see whether you need anything else. So you know IL max 100 milliampere, VPS max is 3.6, VZ is 2.5, IL min is 0. Okay, this value here. VPS min is 3 volt, and that's it. Okay, so you can proceed to put in the values here in the equation as I did here. Alright, and I get the value of IZ max. Alright, the question asks to find the power dissipation. So using P equivalent to IV, so I have obtained the power dissipation here, and the value of the current limiting resistance Ri, I'm going to use this equation, VPS max minus VZ over IZ max plus IL min, and actually Ri is 3.9 ohm. So that's how you solve this example where you have a range of value in your power supply. So one more example is as follows. Again, you are given a range of VPS, you are given the value of VZ. However, instead of giving you a range of IL, the question gives you a range of load resistors. So you are asked to calculate Ri and the power rating, just like the previous example. Okay, this is where student tends to make careless mistake, because you are asked to find what is IL max and IL min, basically. That's why they give you what is RL, right? And student will straight away use IL max equivalent to VL over RL max. Are you going to get IL max using that? No, right? Because it's a fraction. So actually, your IL max is calculated by VL over RL min. Because when you divide to a small value, then you will get a maximum value, right? So this is actually a trick question for you. Alright? So IL min is VL over RL max. And you can see here, this is the minimum value. So then you can just key in the values in the equation here and calculate what is IZ max. Okay? And then you can calculate the power dissipation just like the previous example, and finally calculate the value of Ri. Again, I'm going to use this equation, and I obtain Ri equivalent to 13 ohm. Okay, in this video, I have presented to you the voltage regulator circuit and how to solve it when you have a range of power supply. Okay, so that's the end of chapter 3. Bye. Assalamualaikum.